My name's Keith Rucker. It's good to be back in the shop today after a little hiatus, I guess, over the last couple of weeks. My travel schedule has really had me on the road. Had to make a trip out to California week before last, and then got home late Friday night and over last weekend. Of course, Saturday is usually the day I'm out at the shop working on things, but over last weekend we had a little family thing going on, so I wasn't able to get out here really at all last weekend. And then this past week it's just been crazy with work again, traveling. So this is my busy time of the year at work, and but it is Saturday now. I'm out here at the museum, and we're going to have a good day working. The goal today is to get some Babbitt bearings poured on the Vance Matcher. So we're going to get started on that here in just a minute. Before I do, though, I wanted to tell you guys about a few little things that came in the mail over the past week or two while I've been on my little hiatus from YouTube, and share those with you guys. So first off, I got this nice little hammer here, and you guys, if you watch Tom Lipton's channel, Ox Tools, or you watch Adam's channel, A-Bomb79, both of those guys have also received one of these hammers in recent weeks and have detailed it. But if you don't watch their channels, or you haven't seen these little hammers, I thought I'd just share real quickly with you. So this came from Randy Richard out in California. Sent this to me. He contacted me a couple of weeks ago, wanted to get my mailing address to send me a little something in the mail, so I was real tickled when this came. So he made this out of recycled materials. So it's got copper caps on either side, so it's kind of a soft blow hammer. And these were made out of some copper cap screws that he had laying around, a scrap. The top part of the hammer here was made out of steel, and this is recycled from a concrete stake. And then the handle is aluminum, and that's made out of a part off of a snowmobile track. And of course the caps are threaded into here, and the handle is threaded in. Very nice work, very nice finish. And you know, I guess when I saw these on the other channels, I really didn't appreciate how nice this little hammer is until you get to hold it in your hand. I really like the fact that the handle is made out of aluminum, because it just gives it a good balance. You got plenty of weight up here on the head, but the handle's not too heavy. So we're going to put this in the toolbox, and I'm sure you'll be seeing us use this from time to time. That's going to be very handy. Thank you very much, Randy. I really appreciate sending that along. It's always exciting to get a little package in the mail, something unexpected, and see something nice come in. And I'm always looking to put stuff in the toolbox. So we'll put this in the toolbox right now. All right, next thing that came in the mail this past week was another little gift package, I guess, from Tom Lipton over at Ox Tools. And Tom, a few weeks back, had sent me a little care package with several things in it. But one of the things that he sent me were some of these little Maxi Flex gloves. And since he sent them to me, I have just fell in love with these things. These things are great shop gloves. They're light, they're thin, they've got kind of a rubber coating. It's not rubber, it's from some other material, but give you some grip, but helps keep your hands clean, helps protect them. And with the winter we've been having this year, it also gives a little bit of warmth out here in the shop. So anyway, I've got my first pairs that he sent me, and I've been wearing these for a couple of weeks now, and I'm going to keep on wearing these until I just absolutely wear them out. But you can tell they're getting dirty and starting to get a little bit of wear on them. A couple of places in the gloves have gotten into the grinder or wire wheel or something, so I've got some little scars starting to show up on these. So he sent me 3 more pair, and I'm going to have to order me some of these and keep them in stock out here at the shop, because they're really, really nice. The first ones he sent me were extra large, and that's what I've been wearing. And he sent me 2 more pairs of extra large, but he also sent me a pair of large ones, which are just a little bit smaller. So the extra larges have been fitting real well, and I've enjoyed them. I tried the large ones on at the house, and I haven't used them in the shop yet. And they seem just a little bit tight on my hand, but I'm going to give them a try. And in fact, I may wear some of these large ones today and just see how they are. I think they may be just a little bit tight. They were at the house. They were feeling like it was my fingers were just starting to kind of maybe just not get numb, but you just not really get that good circulation in them. So I think these may be a little bit too tight for my hands, but I'm going to try those. Tom said he likes for them to fit real tight because he can just do more with them. So I'm going to give those a try, but I'm thinking the extra large is going to be where I want to be on these. So we're getting ready to do the Babbitt pour on the machine, but before I can really get everything set up to start pouring the Babbitt, I need to make a little jig, I guess you call it, to hold the shaft into the bearing shells as we're pouring it. And this is what I usually do, or a lot of times will do when I'm doing a shaft like this, is I want to have something that some caps that come in on either side of that bearing shell that will basically serve as a dam to keep the molten Babbitt from pouring out, but it will also kind of hold that shaft and position it into place. So I'm going to make just basically some little spacers, I guess you'd say, that we will turn out of steel and use those on either side, and that will serve two purposes, again, serving as a dam and also to hold the shaft in place. I've got a little drawing here of what I want to do. I've gone out and made some measurements of my shafting of my bearing shells, and I think I've got a plan here on what I'm going to do. So anyway, I've got a piece of steel chucked up over here in the lathe, and we're going to just make 4 of these spacers, 2 for each of the bearing shells, that we will then go out there and put on the machine. So I've got a piece of steel. This is just this is just a little cutoff of some shafting, or actually I guess this is from an axle off of some railroad stuff that the museum got at some point in time. We got some new wheels for our railroad, which we have narrow gauge out here, but the wheel sets that they got were actually standard gauge, and these were like for just some small like carts or whatever that we can roll on the track. But anyway, they had to cut it down from standard gauge to narrow gauge, and when they did, they ended up with a bunch of these little slugs of cutoffs here. And so these are, I think, 2 3/4 inches in diameter, about 6 inches long, real rusted. I mean, this is old metal. I don't know what grade it is. It's steel. It's not cast, but anyway, this is what I'm going to use. This is just, like I said, some scrap material laying around, so we're going to put it to good use, but I have no idea what grade it is. So anyway, I got that chucked up in the lathe. We're going to turn that down. We'll bore it out so that the shaft will fit through it, and then cut some steps on there, as you'll see as we get along. Alright, so we're going to start by just cleaning up this surface here, getting a good clean surface on there. Then I'll punch a hole in there, and we'll come back and finish that up after we get the hole bored in. So let's see where we're at on the lathe here. The 80, 90. I'm going to try for a true 100 thousandths cut here, and which take 200 thousandths off the total diameter. Very nice. I was making a nice blue chip here. Cut very well. I'm pleased with that. I'm just recently upgraded to this larger tool holder, and I can really put some tooling on here that's more appropriate for this size machine. So anyway, I was tickled to make that big heavy cut there, and it looks great. Alright, let's punch a hole in this now, and we'll come back and finish that outside diameter after we get a hole bored through here to the right size. Anytime I'm boring and turning outside diameters, I typically like to try to get my inside diameter turned about where I want it first, and then I'll come back and finish up my outside. You know, that's just, I guess, personal preference. That's just the way I like to do it. So let's get a hole punched in there and we'll start going. All right, we got that drilled out to 1 inch. Now we're going to start working on boring that out to the 1 7/16 inches that we're looking for. It'll take about a 50,000 spot on that. We've let this cool off for a little while now. I've switched boring bars. I said a while ago I had a 1 inch boring bar. It was actually a 3/4 inch, and now I've got my 1 inch boring bar in there, which will give me a little more rigidity as we go down here. We've let this cool off. I've remeasured. I've got about 30 thousandths of an inch to still take out. So we're going to come in and touch off with this boring bar. Probably take about half of that amount with the first pass. Then we'll get a good clean measurement and know how far we need to go on the second pass to make our final cut. All right, we got about 12 thousandths to go. 2, 4, 6, 8, 10, 12. This should be our final pass. All right, that's perfect. See that action where it's springing in there? That's the air suction holding that shaft. That means I got a good tight fit in there. So that's going to be perfect. Now if I can get it out, I got suction holding it in. I want to jam my, there we go. All right, we got our outside diameter now to go. I got about 170 thousandths yet to cut on this pass. So we'll go back in here, calibrate, take about 100 thousandths pass, and then finish it up on the next pass. This outside diameter here is not critical. I'm shooting for about 2 1/4 inches, but you know, no tight tolerance on it at all. All right, that should be about 100 thousandths, so 50 thousandths on each side. All right, 2 and .250, right on the money. All right, now I want to cut a 1 3/4 inch step in here, 1/4 inch deep. So I'm going to make a little witness mark there at 1/4 inch. And that's close enough. No critical here at all either. All right, we got about 100 thousandths to go there. spacing on that. Right on the money. Good job. All right, now we're going to come in here and part this off. Cut that speed down. Thought I'd show you guys the tooling that we use for doing this. So for the regular just outside turning, I'm using this CNMG bit now, or cutter. That's really the first time I've had a chance to use this on that machine doing some heavy turning, and I was very pleased after upgrading. So just to give you an idea of what I have been using, this was the cutter that I had been using with the smaller. This was for a 10-inch lathe, some mold tooling that I had from an old machine, and I recently upgraded to the CA holders, which gave me the capacity to go up to this larger turning tool. So because of that, I'm now able to make much bigger, heavier cuts and work a lot faster and more efficiently on this machine. So I know a while back I had some guys giving me a hard time because I was making light cuts on my machine and saying that my machine was junk or whatever, because but reality, it was because of my tooling. My tooling was what was holding me back from making those 100,000th and 200,000th cuts. So with this new CA holder and using that CNMG carbide insert there, you could tell I was very easily able to make a 100,000th cut, reducing the diameter by 200 thousandths. So for my boring, I started out with this smaller boring bar here. This is a 3/4 inch diameter, and it has that same CN geometry cutter in here, but just a smaller scale. And this is one I've been using for a while. I've had for a while. But once I got that hole punched out a little bit bigger, I switched over to this 1-inch boring bar that again has that same CNMG cutter that I'm using over there, little bit bigger cutter. So the smaller boring bar, obviously I punched a 1-inch hole in there, so I wasn't able to get this one into the hole right away. So I had to start out with a smaller boring bar. But just really about as quick as I can, I like to go to the larger diameter boring bar because it just gives you more rigidity, and it's going to have less flex in the tools, and it's just going to work better. So I always try to use the largest boring bar that I can. Now for the parting operations, I was using this Loris parting tool holder that's just got a high-speed steel, or actually I think it's this cobalt here, cutting parting tool, and that just goes right up in there and slices it off. You can get these with inserts as well, and eventually I'll probably get a one that I can put an insert in that will fit into this holder, but for right now I'm just using the high-speed steel. So anyway, that's just a little bit about the tooling we used over there, and I'm really tickled to have been able to finally get upgraded in my tooling size here to something that's a little bit more appropriate for the machine that I'm working on. As for the parts we were making, you can see now I've got 4 of these. So we bored that inside diameter so that it would fit on the shafting that we'll be using. There we go, have a little burr on there. So that's going to fit onto the shaft that way, and then we'll take another one and put on this end. And basically what this will do is this is made, this inside diameter here is the same diameter of the little bearing caps, and this was basically just sitting to the bottom of that bearing cap, and then the outside diameter is just to form a dam to keep the Babbitt from pouring out. So we'll do this on both ends of the shafts, and basically what these are going to do is it's going to serve as a jig that will go ahead and position my shaft right into those bearing caps or bearing shells, so that my shaft will be held in the proper position, and then I can then pour the Babbitt around them. So this is now ready to go. So let's go on out to the machine, and we'll go ahead and get the shaft set up and get ready to start pouring some Babbitt. I've got the shaft kind of dummied up, mounted on the machine out here now, so you can see how these spacers are working, or these little jigs are working. So that lip fits on the inside of the bearing shell. The shaft's going through it, and of course the outside you see is damming up against the outside, so the Babbitt can't pour or flow out of there when it's in a molten state. So, and then at the same time it's holding the shaft in the proper position, which is about halfway into that bearing shell. For the Babbitt to go in. So this is exactly what we're after. Our shaft is now installed in the machine, and you know, everything's just like we want it. So now we're going to go ahead and start getting everything prepped for the Babbitt pour. Now that we had everything dry fitted together, made sure everything was going to work, now we want to really start getting the shaft prepped for the Babbitt pour. So before I do that, though, let me just mention down here on the bearing shells where we'll be pouring the Babbitt into, I've cleaned those up. I've taken a wire brush. I've tried to get them as clean as possible. We've got the little holes drilled into the shell itself that the Babbitt will flow into and keep it from turning, and we showed that in the last video. Those are just some little keys to keep that Babbitt from turning in there. So that's already down there. So now what I want to do is I want to take on the shaft itself, I'm going to take the acetylene torch and I'm going to smoke the shaft with just carbon soot. And the reason I'm going to do that is that once the Babbitt cools, we want to have some type of release agent on the shaft itself so that it's not going to stick to the actual shaft. We want it to stick to the bearing shells, but we don't want it to stick here. So an old-timer's trick that I've always learned is just take your acetylene torch, don't have any oxygen running, where you got good smoke going on it, and just put a good coat of carbon on there, and that will give you a good fireproof just material between the Babbitt and the shaft itself, so that it will come apart a little bit easier. So I've got my torch ready. We're going to go ahead and blacken or smoke these the shafts and get them ready to go. And turn my gas on first. All right, now that I have my gas turned on, this ought to work a little better. There we go. So I'll turn that flame back to where it's just barely coming out, and I got a lot of smoke coming off of it. And I'm just going to run that across the shaft, and that's going to put the carbon on it. Works better when the wind's not blowing like this. So there you see the carbon blacking on the shaft, and that's just what we're looking for. And now we're going to position the shaft back in. Now we have the shaft and the spacers all in place. The next step here is we want to actually put a little bit more damming material in here to make sure that we don't get any of that molten Babbitt pouring out around these spacers. While the spacer themselves should do a pretty good job of holding the Babbitt back, that's not a machine surface that it's fitting in. It's not a super tight fit in there. So I'm going to add some more damming material. And what I'm going to use is this material here. It's called Babbitt Right. And this is made for pouring Babbitt. It's just a Play-Doh type consistency. You can roll it in your hands and get a string of it going. Stuff I've got is pretty old, and it's starting to get a little stiff. You can reuse it over and over again, but it's a heat-proof material. Back in the old days, it actually had asbestos in it, but the more modern stuff is asbestos-free. And I know that I bought this, I probably had this 10 or 15 years, but probably 11 or 12 years, I guess. but I know this is some new material. Unfortunately, the makers who were making Babbitt Right have quit making this, and it's no longer available. So I'm going to have to find a new material, because I really need to get some more of this stuff in for doing Babbitt pours, because like I said, this stuff is just getting old. But let's get that a little bit thinner. That's probably fine. So all I'm going to do is I'm just going to wrap this around the edge there, and I will just use this to make a really good seal around between the bearing shell and my spacers that I made. And I'll do this on all of them, and again, that's just to make sure that I don't have any Babbitt escape and come out around this joint. I'm also going to put some around the shaft itself here. That's just another place that the Babbitt can come out. That's a pretty tight fit in there. I don't think it would come through there, but it's easier to put this stuff on and not worry about it. So now I've got a good seal all the way around that, between the spacer, which will serve as a dam, and then the Babbitt Right as a backup dam. I should be able to contain my Babbitt material in the shell where I want it when I pour. So we're ready now to start putting some heat on some of these parts. So let's get our torch lit up here, and we'll get going. So got the torch going. What I'm going to do is come down here and turn on this stove, and on the stove I have a ladle with my Babbitt in it, and go ahead and just kind of preheat that with the torch as well, and we'll get this started melting. So the Babbitt that I'm using today is a tin-based Babbitt. Babbitt comes in a couple of different types. Really, well, there's a lot of different kinds of Babbitt out there, but they all really kind of boil down into two basic types. There's a tin-based Babbitt and a lead-based Babbitt. And of course, Babbitt is an alloy. A lot of different metals used as a bearing material, actually a very good bearing material. But when you're buying Babbitt for a machine, you need to look at how fast the shaft is that you're going to be operating to decide which type of Babbitt to use. If it's a fairly slow turning shaft, when I say slow turning, I'm saying probably up to a couple of thousand RPM, you can use the lead-based Babbitt, which is much cheaper to buy. But when you start getting into high-speed applications, such as a cutter head on a joiner or a planer like we have over here, you need to use a tin-based, T-I-N, the metal, Babbitt. And the tin-based Babbitt is actually rated for higher speed shafts. So today what we're using on this shaft is actually a tin-based Babbitt. I had previously melted it down, which is why it's not in an ingot, but I do know exactly what this is. All right, that's started to melting there. We're just going to let that go. And while I'm working on that, or while that's melting over there, I'm going to start putting some heat on the bearing shell and the shaft, just kind of slowly heating this up. But back to the Babbitt itself, for what we're using here is a product called Adamant by Magnolia Metals Company. They're still in business. You can still order this. And that's the material that we're using for Babbitt today, which is a tin-based Babbitt for high-speed applications. All right, what I'm doing now is I'm just putting some heat on the bearing shell, on the shaft. The goal here is I want to get some warmth in these. It does not have to be red hot. It does not have to be, really all it needs to be is a couple hundred degrees. Babbitt by itself will melt, anywhere, and I'd have to look up the specs on this, but it's probably going to be around 700 or 800 degrees is where this material is going to melt at. So the goal here is just to get some heat into these shafts, into the shaft and into the shell, just so that when I pour the hot metal in there, it's not going to cool and solidify real fast, just right on contact. So again, the goal is not to get it red hot. The goal is just to get some heat into it all, so it doesn't cool the Babbitt too quickly as we're doing the pour. One question that I was asked prior to doing this was I going to tin the actual bearing shell? And I'm not doing that. And what the question was about is you can take a material and actually coat the inside of the bearing shell with tin. And what that does is it allows the Babbitt to stick to the shell better. Because these shells have the little keyholes drilled into them that's going to grip that Babbitt, it's really not as necessary to tin them as if you had a real smooth shaft. So a lot of times in automotive applications in particular, where Babbitt's used on like crankshafts, they will tin those because they're actually pouring the Babbitt into a machine surface, and it can slide and slip in that very easily. You need to have something for it to stick to. But again, in this application, it's not necessary, and we're not going to put any tin on these. So as this Babbitt is warming up and heating up, it starts getting molten, and what will happen is you'll get some impurities that will come up on the top of the surface, and you just want to skim those off. So I'm just using a little pine stick here, and we're just going to take this and just kind of throw that right out onto the ground where it's not going to hurt anything. The skimming material there. Now we need to get the Babbitt and the ladle heated up to the proper temperature, and I don't have any kind of fancy thermometer or anything to do that, but an old timer's trick is, again, just use a pine stick, and when you stick it down in there and it starts to char the stick, your Babbitt is hot enough. So it's not quite charring the stick yet, so we're going to continue letting that heat up, and I'm going to also continue just kind of skimming the top there to get those impurities off. I got some heat in the shafts now. I'm going to let this heat up a little bit more and get it closer to pouring temperature. Then I'll real quickly throw just a little bit more heat on the shafts again, and then we'll do the pour. While this continues to heat up, just a little bit more about Babbitt. Babbitt bearings have been around for a long time. Isaac Babbitt kind of invented the materials back in the I think it was in the late 1800s. I'll look that up and put it up on the screen to make sure I'm telling you correctly. But it was used as a bearing material, and all this is a soft metal that when you put oil on it, the shaft is actually running on a layer of oil on top of this soft metal, and it works very good as a bearing material. Of course, in the early to mid 1900s, ball bearings started replacing Babbitt in a lot of applications as they became more available. But even today, we still use Babbitt in a lot of situations where you have particularly a shaft running or on something, and also in very large applications. I've been told that still on a lot of ships that are being made now, where you have a really big propeller shaft and you need a very solid bearing material, they're still using Babbitt in those applications. I've heard they still use it in powered dams or hydroelectric plants and the big generators where it's just too big for a ball bearing. Babbitt's still used in those applications. And even some precision lathes are used with Babbitt, or sometimes they use bronze in those now, because with ball bearings, as the shaft is rotating, you actually get a little bit of vibration in that shaft. Whereas in a good tight Babbitt bearing, you get a very smooth running shaft with very little vibration in it at all. So it actually still has applications and uses today. But of course, the downside to Babbitt is that it does require a little bit of care and feeding. You have to take care of those bearings. You have to keep them oiled. You have to make sure they're properly adjusted. And most people don't want to fool with that. And really, the convenience factor was probably the main reason people started going to ball bearings in a lot of situations. So let's check the temperature again. We're getting real close. It's starting to char the wood here a little bit. So we're going to probably skim this one more time and put some more heat on our shaft, and we'll be ready to pour these bearings. Alright, here we go. Ladle full of hot Babbitt coming. Oops, spilled a little bit there. Alright, that one's done. Now we'll put some heat on the other side, on the other shaft, and get that one poured. Alright, we're going to just let that cool now, and we'll come back after an hour or two. I'm going to go grab some lunch and pull that out and see how it did. Alright, we let that cool for about an hour and 15 minutes and pulled the shaft, and you can see we got a very nice clean bottom bearing here. This is on the left side of the machine, and over on the right hand side of the machine, same thing. We got a real nice clean bearing shell there on the bottom. So now we're going to clean up the tops and get ready to pour the top half. Alright, try to get you guys in here where you can see. It's kind of awkward working on the machine, just real tight quarters in here. But we got a little bit of Babbitt that kind of spilled over the top of the casting, so I'm going to try to clean this up. You know, if I can push it off or scrape it off like this, it makes it a little bit easier to get cleaned up. But sometimes I'm going to have to file that. Let me go grab a little hammer where I can tap that. Alright, now I'm just going to take a pretty coarse rasp file and just file the top of this down. We just want that to be flush with the top of the bearing cap. And that looks pretty good. Let's get the other side now. Next step here in getting ready to pour the Babbitt in the top of these top halves of these caps is going to be to get some shims made to go between the two pieces. And the reason we want to put shims in there is as this Babbitt wears, you can always pull some of that material, pull some of those shims out and tighten these bearings up over time. You can use a lot of different materials for making these shims. As I've taken old machines apart and old bearings apart, I've seen all kinds of materials, from cereal boxes, cardboard, just you name it. Sometimes you'll see metal shims put in there. Typically what I like to use is just plain gasket paper. I like gasket paper because you can buy it in different thicknesses. And it is somewhat heat resistant, so that when you're pouring the bearing, you don't have to really worry about the material catching on fire and burning up. Because again, the molten Babbitt is only it's less than 1,000 degrees, and most of this material will withstand heats at that temperature for at least a short period of time until it cools off. And the other thing I like about gasket paper is that it's fairly easy to cut it and to get it to the shape and that you want. So what I want to do is I'm just going to lay a piece on here, and I'm going to let this stick over the edge just a little bit because I want that to come up to the shaft in the bearing cap there. And to get the shape that I want, I'm just going to use a ball peen hammer and just kind of go around the outside of this, just tap around it, and you will see an imprint on the other side here that shows the shape of the of what you're doing. So, and then I will I'm just going to take a pair of scissors and just kind of rough this out. You can actually tap on it enough with a hammer that it will just tear off to that shape, and sometimes I'll do that, but for right now I think I'm just going to use the scissors. Now they got the shape on there. So now I've got a piece that matches that shape there. I need to get the hole in there. So again, you know, just tap it with the ball peen hammer, and as you see, it just comes right out. And now I've got a shim that's made to fit this right here without any problem. So I'm going to make several of those now, and we'll go bolt these down and get them ready to pour. We pulled the top bearings off now and cleaned them up. So start off, this was the one that was on the right side of the machine. We got a good pour on it. I do have a few air bubbles in the top here. That's typical when you're pouring a top bearing, just because there's no place for the gases and the steam and everything that's coming off of that to go except out of the pour hole, and a lot of times you'll get some air bubbles in the top. It's no big deal because you actually need some recesses in the top of the bearing anywhere as an oil reservoir. In fact, we're going to be scratching in some grooves in there anyway later on, so I'm not worried about that at all. That's, like I said, actually really pretty good because it gives you an oil reservoir. Now, the one that is giving us some trouble, though, is the first bearing I poured, and I noted on the video there where the dam had leaked and we were getting some Babbitt pouring out, and I was able to get it to pour solid, but I had to stop and repack it. So basically what I ended up with was 2 layers of Babbitt in this shell, where it had done the first one and then it kind of got hard, and then we poured another layer on top of that. And I really don't like that kind of a situation. That happens from time to time where you just don't get a good dam, and anyway, that's typically a bad thing to happen in a Babbitt pour. When I pulled it out, I was really kind of surprised because I had a really nice looking bearing surface in there, but as I was cleaning it up, I put the file on there and I actually broke this piece out. So it was real thin right there where I had the bottom layer and then the top layer on top of it. So what we're going to do with this one is this a mess up, and we're just going to melt that Babbitt out. We'll reset it up and we'll re-pour this one bearing cap here. That's really the nice thing about Babbitt, is that it is very forgiving. If you make a mistake or you get a bad pour, you know, all you've lost is some time. You just go in there, melt it out, and start over. So we're going to go, we'll melt this out, set it back up on the machine, and hopefully get a good pour on the second try. So the first step here is we're going to melt this old Babbitt out. So I'm just going to melt it right into the ladle there, and we'll get the stove going to start melting this. So let's get the torch lit. And we'll just melt that right out. And now we're going to smoke this shaft and get it ready to go as well. And just like before, we'll just use a torch and put a layer of carbon on there, and that's probably good. And get the shaft positioned back in here. So put a couple of shims in the back. We'll put a couple of shims in the front. Slide this bearing cap in here. And get some bolts in there. Alright, that's ready to put some heat on. Alright, we got a good dam on there. Put some heat on these bearing shells and I think we'll be ready to pour. Alright, this time we got a much better pour. Still got just a little bit of an air pocket down here in the bottom of the bearing, but again, that's not going to be a problem because that's just going to be able to serve as an oil reservoir. So I'm going to take this and just kind of clean this one up and get it ready to go on the machine. Alright, that's pretty much ready to go now. Like I said, we got a little gap right there, but that's going to be real good. The oil hole is going to come in right there and that'll give us a reservoir on the top. Alright, we're just about ready to start start on the scraping, but I wanted to show you these scraper tools that I use for Babbitt bearings. These are just some miscellaneous scrapers that I've picked up over the years at different places, but as you can see, it's kind of a curved shape here. And it has a good scraping edge on the side there, and we'll get in here and scrape these bearings. This is a triangular scraper here that comes in handy as well. But anyway, these are Babbitt scrapers, or scrapers in general, but very often we're used for Babbitt. And I've got a collection of probably about 10 of these different sizes and shapes or whatever that I have put together over the years that I use for scraping Babbitt. So I've gone ahead and drilled the oil hole through the cap and into the bottom, and as you can see, these holes in here will just serve as oil holes or oil grooves. But now we're just going to take these scrapers and if I can get this to stay in the vise, and I'm just going to real gingerly just kind of scrape off the high points in this bearing shell. I'm really not trying to do a whole lot of scraping right now. I'm just trying to really just get those high spots knocked off, and then we'll go put it on the shaft on the machine and tighten it down and see how it feels. But again, I'm just trying to knock the high spots off, and I use a couple of different scrapers for this. That's going to be a good starting point. Alright, we're through with this Babbitt pouring job. Forgive me, I basically on the bottom shells, I went in and scraped them about like I did the top ones. It's just so tight down in here, I just didn't have room to get a camera in there to show you guys that part of it. But basically the same process. I just did some light scraping on them. I then put my shaft in and did a couple of test fits, tighten them down, and doing a little bit more scraping. In a high-speed shaft, this shaft here is not really going to be turning all that terribly fast. But like on a cutter head shaft, what I would do is I would actually take the time to really get it scraped in super well by going in and using some bluing, finding the high spots and trying to get about 70 to 80% contact surface area in there. And when we get to doing the cutter head Babbitts over here, I will show you the process of really taking the time to get it scraped in well. On these, again, it's a fairly slow turning shaft. It's not as critical. So you know, if you got 50-60% contact in that shaft, you're going to be fine. And the Babbitt will wear in over time as well. So anyway, we got everything on there. Just clamped it down there, put some oil in the journals. I've got the pulleys and everything and the gears on here now, and it turns very easily, but yet there's no movement in the shaft. I mean, I'm pulling on this and I can't feel any shaft movement in there, which is exactly what we want. So this is going to work real well. You can see everything's geared up here, and it's actually turning the feed rollers on both sides as well. So, and of course this pulley here is my loose pulley, and as we talked about before, there's actually be a little shifting fork here that will shift the belt from one of these pulleys to the other. And if it's running on the loose pulley, of course the belt's running, but it's not engaged. But then this pulley over here on the back side is tightened up on the shaft, and when you shift the pulley over there, the shaft starts turning and your feed works engage. So that pretty much wraps up the Babbitt pouring for this shaft. I've still got some more Babbitt to pour on this machine, so you'll likely see a few more videos on this subject as we move along. It's not rocket science, folks. It's pretty low-tech technology, to be honest with you, and it's really quite simple to do this. You know, if you got a machine that has Babbitt bearings on it, the first thing I'd tell you is, number one, don't be scared of it. With those Babbitt bearings properly adjusted and maintained, that machine is not something that you just want to discard just because it has Babbitt bearings. I see that a lot. People say, well, I don't want that machine because it doesn't have ball bearings. There's nothing to be scared of with Babbitt bearings. You just need to make sure you keep them oiled, and you may have to do a little bit of adjusting to them. In most cases, a machine even that has warm Babbitt bearings, you can just take them apart, take some shims out, do some scraping, and not even have to re-pour the bearings like we did here. But even if you do, it's not a very difficult process. And you know, it's another thing, as you saw here, it's not a one-time do all or die. I mean, if you mess it up, you just melt it out and start over again. So the first time I poured Babbitt bearings, I think it took me 3 tries to get one that looked good or that I was happy with. But you know, with practice, like anything else, it gets easier and easier. So anyway, there's your process. I'm going to go ahead and paint everything up down here, all the raw metal on here, so it doesn't start rusting. And you know, we're quickly making progress on this machine now. I'm not sure exactly what my next step will be. I will tell you guys that this coming week again, I'm going to be traveling a good bit. So I'm headed out of town later this week. I'm going to be gone this coming weekend. Actually, this weekend I'm headed up to a friend of mine's house up in North Georgia. He has a little home machine shop, and we're having a little gathering of a bunch of friends up there, mostly people over on the old woodworking machines forum. So we're going to have a little get-together up at Mike's place. And I'm going to take the video camera along. There's going to be all kinds of neat projects going on up there. And I'm going to try to shoot some video of some stuff we're doing up at his place. And don't be surprised if you see some of those show up here in a week or two. But when I leave there, I'm actually got to fly back out to California for a meeting at work. And I'll be out there most of next week. So it's probably going to be another really 2 weeks before I can get anything put back up on my channel. But so bear with me, hang with me, and we'll look forward to seeing you guys. For you people who are just recent subscribers, thank you for subscribing. To all my subscribers, thank you. Comments, keep them coming. I read everyone, guys. I don't have time to reply to each and every one of them, but if you have a question or something like that, I will try to get back to you on the comments. So I enjoy reading your comments, even though I may not reply to every one of them. So keep that up as well. So thank you for watching. Thank you for being here, and we'll get another video up as soon as possible. Thanks.